Okay, so in this video, I am going over the odds for the Unit 2 test review. I was hoping to do all of them, but to be honest, I think that video would be way too long and nobody would watch it. So I'm gonna do the odds. I'm gonna give you guys a key that is very detailed and has lots of hints on it that you can use to help you on the evens, and you guys can work together. Okay, so again, we're gonna do the odds. Let me just circle those real fast to keep me on track. 10 is going to be a challenge question, so you do not need to do number 10 unless you're up for the challenge, at which point use the key if you need the help. So again, I'm just going to go through and do all of the odds to give you an example of each. Okay, so starting in this first section, this is the only section where I need to see work for simplifying radicals. The rest of this review, you can use your calculator to simplify radicals. It's gonna make your life a lot easier and gonna save you a lot of time. But again, in this first section, I do need to see it. So there's a couple ways we can do number 1. First off, if you recognize your perfect squares, 196 is 14 squared. So the square root of 196 is just 14. If you went straight there, awesome, great. My pen's not doing very good already. Okay. The other way that you could have done this is you could have split 196 up to be 49 and 4. Again, you go through, you're checking all of the perfect pairs because a square root undoes a pair of numbers. So we're checking all of our perfect squares because those are all pairs of numbers. And then we can simplify that 49 to be 7, or the square root of 49 to be 7, and you can simplify the square root of 4 to be 2, which is another way that you would get 14. But either way is perfect. They're both mathematically valid, and you get 14 either way. On number 3, we would start by rewriting that 5. It's just going to kind of trail along for a while. And then again, we're looking for a perfect square that is hidden in 112. So 112 can be split up to be the square root of 16 and the square root of 7. If I'm going too fast, please pause the video, and then you can have as much time as you want. I can rewrite this as 5 times 4 times the square root of 7. And then I can simplify 5 times 4 in front to get 20 square root of 7. All of these can also be checked in your calculator. So on number 1, you can put in the square root of 196. It will tell you the answer. On number 3, you can put in 5 times the square root of 112 in your calculator, and it will give you that answer as well. Most of what I am checking for is the work. Okay, so do not go straight to that answer, because if you do, I will give you probably 0 points, to be completely honest. Number 5, we're multiplying, so we do need to remind ourselves, how do we multiply radicals? We multiply the outsides first. I would get negative 21. Then we multiply the insides and we leave them under a radical to get 180. We would then go through and check for perfect squares, and there's a couple perfect squares that work with 180, but again, we need to find the biggest one. So I believe it would be square root of 36 and 5, but again, that's a pause and figure that out and then resume the video. Now, the reason I picked the square root of 36 is because that is a pair, so I can rewrite it as just a 6 because that square root is undoing the pair of 6s. And then I can finish with multiplication in front. So again, this is another one where you can put it in your calculator and you can get the right answer and then work backwards to figure out how you would have gotten there. That is a strategy that I'm totally fine with on the test, but I must see your work. The next section's over the Pythagorean theorem, and what you have to remember on this is we have 3 variables, A, B, and C. And C is always the longest, and it's the hypotenuse. So when I go through and I am trying to find, a missing side, a hypotenuse, or a leg, you just have to keep track what is A, B, and C, and then you're plugging into that equation and solving. So on number 7, the hypotenuse is across from the right angle, so I'm going to make that C, and then A and B are the other 2 sides. So I would need to go through and write those into the Pythagorean theorem. So 9 squared plus 17 squared equals x squared. We can use our calculator if we don't know those perfect squares. So it's 81 plus 289 equals x squared. We have like terms on the left that we can combine to get me 370 equals x squared. And then the only way to undo something that is squared is to square root both sides. Again, at this point, you can use your calculator to see if the square root of 370 simplifies. When I type it in my calculator, it leaves it as the square root of 370. I'm told to write an answer as a simplified radical, so that would be the simplified radical because it doesn't really get any nicer than that. And then I can hit the arrows right above the enter button, so just right above the enter button to get the decimal of 19.2. Same process on number 9. So across from the right angle is the hypotenuse. The legs are the other two, and those can be in any order. We write out the Pythagorean theorem. So x squared plus 6.8 squared equals 8.1 squared. Again, we're going to simplify everything down, so x squared does not change. But I am going to have to figure out each little part. And keep all of your decimals until the end. Try not to round until the very end. So since in my calculator I only have 2 decimals, I'm going to leave them there until I get all the way to the end. Now we can subtract 46.24. I get that x squared equals 19.37. And then you're only left a place for a decimal on this one because you were taking the square root of a decimal, so it's not really going to get any neater than that. I'm trying to write it. 4.4. Oh my gosh, let me change pens. All right, I can't find the other one, so we're going with this. That's a 4. Jeez. Okay. Technical difficulties. My apologies. There we are. Again, the next one is a challenge. I found my other pen. Here we go. All right, so on the back, a couple different things going on. We have a couple word problems. My suggestion is to draw it out. And then we're going to talk about some of our inequalities with triangles and special right triangles at the bottom. So for number 11, it says, an Olympic-sized swimming pool is approximately 50 meters long by 25 meters wide. What distance will a swimmer travel if they swim from one corner to the opposite? Draw a picture. So again, we want to start by drawing a picture. I can draw a pretty nice little rectangle because I'm on Notability. You guys can do your best. And it's 50 meters long, so it's 50 on both of these sides. And then the other sides are 25. So I'm going to write that in. And then it says, what distance will a swimmer travel if they swim from one corner to the opposite? Draw a picture. So if somebody is swimming diagonally across this, how far would they swim? So that's going to be our x value. That's what we're looking for. And this is on a right triangle if you only look at half of it, right? So we can ignore this section, look at that bottom right triangle, and we will be able to use the Pythagorean theorem. So I'm going to go through and label. Across from my hypotenuse, or from my right angle, is my hypotenuse. The other two sides are legs. I would then go through and set up the Pythagorean theorem. So 50 squared plus 25 squared equals x squared. Then we can go through and simplify those with our calculator. So 2,500 plus 625 equals x squared. I can combine like terms. 3,125 equals x squared. And then to get x squared alone, or x alone from x squared, we can square root both sides. So as a decimal, this is 55.9. And you do need a unit, it is meters. All right, on this next section, we practice this in the notes, so if you need those, help you. But we have a couple tests that we're gonna do, and I can write them out on the right side. So first we're gonna say, is this a triangle? And what you're looking for here is A plus B has to be greater than C. The reason for that is if you have legs that do not add up to at least your hypotenuse, there is no way to create that triangle. So again, think of a base that's 8 and two side lengths that are 2 and 3. There is no way that those are going to connect into a triangle because there's just not enough there for it, right? That 2 and that 3 are never going to be able to touch to get me the triangle that I would need. So that's our first test. After that, we look at the Pythagorean theorem again, and we try to figure out what type of triangle it is. So if I do the Pythagorean theorem, and I end up with a squared plus b squared being greater than c squared, that is an example of an acute triangle. If a squared plus b squared equals c squared, that is a right triangle. And if a squared plus b squared is less than c squared, that is an obtuse triangle. So those are the tests that we are doing with these values. So the other thing we have to check is that we have our small sides first, because again, remember your largest side is going to be your hypotenuse. So I do like to go through and write in A, B, and C. Looks like those would work, and looks like these would work as well. All right, so first let's test the type. On example 13, we want to know, or not the type, if it's a triangle or not. So 20 plus 21 has to be greater than 29. 20 plus 21 is 41, so that is true, and it is a triangle. Then we are testing the type, and you can use your calculator to help you on this. So what is the type? 20 squared plus 21 squared is related to 29 squared. We don't know how yet, so I draw in that box, and we'll fill in the inequality in a second. Then I'm going to go through, and I'm going to figure out 20 squared plus 21 squared, and I just did that whole thing in the calculator to get a total of 841, and we're going to compare that to 29 squared, which is 841. So those are equal, meaning this is a right triangle. Again, if the Pythagorean theorem works, and in that example it did perfectly, then that means you have a right triangle as opposed to acute or obtuse. In the next one, let's see if it's a triangle. So we would do 3 plus 15 has to be greater than 18 and figure out if that's true or false. Since this is equal to 18, 18 is not bigger than 18, so we would say, no, this cannot be a triangle. Because basically, if you have a base that's 18, and one side's 3, and one side's 15, they're not going to be able to connect to get you 18 total. Because these two are the same distance as this one. So essentially you'd have like a flat line on top of a flat line. It's like that, and a triangle cannot happen. So we don't even have to test the type of triangle. When we say it's not a triangle, we are done. All right, the last section is our 45, 45, 90 triangles. And with these, I think the easiest thing to do is draw in a 45, 45, 90 triangle. Right angle, 45, 45. And then remember that if you have two sides that are the same, the legs are identical. And to get to the hypotenuse, you multiply by the square root of 2. So you end up with x square root of 2. Or to go from the hypotenuse back to one of the leg lengths, you divide by the square root of 2. And again, that's all in your calculator. So this little image, I'm going to have you guys do a note card on your test, and we're going to make it right before the test as a class. But we're going to put an image like that onto that note card so you can reference it. So as I look at this, the hypotenuse is across from the right angle. So that means these two legs are the same. They're both 5. And then to get from the leg to the hypotenuse, I have to multiply by the square root of 2 per this little chart up here. So it's going to be 5 square root of 2. Again, you can do that in your calculator and write your answer as a radical. For number 19, I need to find the leg lengths. My hypotenuse is 19 square root of 2. So I can divide by the square root of 2. And again, I can do that in my calculator. 19 square root of 2 divided by square root of 2 to get just 19 as one side. And again, it matches on the other side. So they would both be 19. All right, that's it for the notes. Thanks for watching.